Well, welcome everyone. My name is Earl Beede, and I'm a senior fellow here with Construx here in Bellevue, Washington, where the weather outside, I look out my window here and it looks partly cloudy, but more clouds coming in. We're actually set for some rain this evening here, but generally not too bad. So looking forward to our time together today. And we're going to be talking about 10x software development principles. Now, this is a little different to what some people might expect. That when we think about software development, we might think about particular practices or tactics, but we're going to take it up a notch a little bit here and talk about 10x software development principles, things that make teams far more productive. Throughout the session, I've got a coworker standing by on chat to answer any specific questions you have about the technology and to queue up questions because I'll save some time for Q&A at the end. So hopefully you'll be interested enough to start thinking about how can I use these principles to help me drive up my productivity on the team. Because when we think about software productivity, when we think about how we could be 10x, 10 times better than we really are, that's really an important thing to think about. And so think about how these principles, as we go through them, might apply to your particular organization, how you can start driving more productiveness on your team. So with that, let's go ahead and start talking a little bit about what the 10x software development means and what we sort of mean by 10x, because we've been trying to do software great for many, many years. And I keep getting my camera sideways, but I look at the picture here and it looks straight on to me. And it's right one lit. So my coworker telling me he's seeing me sideways, but all my images I see on here are straight on. Okay, no worries. All right, he's seeing me through a different camera. I have like 6 cameras. Fair enough. All right, so going back to the principles, thank you for my coworker there to alert me that my face was going sideways. But let's go ahead and start talking about, we've been trying to do 10x software for a long time. And we've tried many, many different kinds of approaches to doing 10x development. We started out with just, ad hoc coding with the first computers, punching in our cards and plugging in our wires. But then we came to things like structured development. Then we started building tools to help us do that. And we tried to find lots of different ways to help us build this off. RAID, remember anyone? Rapid application development, might be some gray beards in there like me out there in the world. Commercial off-the-shelf software was going to be the savior of everything. We're just going to buy it and plug it together. Then open source with all its eyeballs was going to save everything. Then came Agile, then Lean Agile, and Agile Lean, and now DevOps. And there's probably one coming down the pipeline. So we've been trying to figure out ways to get us better at developing software for some time. And so we tried all these things. We also tried some other approaches that didn't work quite as well, but they didn't give them names because they didn't work so well, but they sounded something like this sometimes, right? They sounded like, we'll just code it together and we'll start getting some feedback. This is one I still see popping up very regularly now. It's just like, let's fail fast. That sounds like a really good thing. And I'm here to suggest it's not a great thing, that failing fast is not as good as succeeding fast. And we'll try to take that up a notch here as well. I've seen this one a lot. Sure, this will scale from my Excel spreadsheet to the entire company. This used to be really popular, especially when Excel first came out, but we still see it with small apps, small prototypes. People think it's wonderful. Now let's roll it out all over the place, and somehow the scaling just doesn't work. That wasn't a success to get us to 10x. And whenever I hear the phrase, it's just a, right? When someone says, it's just a, I know I'm in trouble because they've underestimated this thing, usually by an order of magnitude, and it's much bigger and much more complex than I've ever seen before in my life. So those are some forces that we haven't seen. So what does it mean to be 10x? What do we want to say when we're 10x? Well, first it's clear, what do we mean by just being successful? And I think we can all agree on what successful means. It usually means that we're at least on time, right? And the time here is the agreed to time, not necessarily the time that is dreamed up, but an agreed to time. So we're on the time that we agreed to, and the same way with the budget. It's on the budget we agreed to, that it seems like a reasonable budget and that we were able to spend the amount of money and staff hours necessary to make that happen. And then with our desired functionality, that is, it's all the things there that we agreed to and that we said is going to be there at a quality level that is acceptable to both internally to our ongoing development efforts and our customers. That's what we're looking at. But I also like to add a fifth to this, just basic software development success list, is that the team does it in a sustainable way. That is, that the team is ready by it. So what we mean by software development success is that we're doing it on time, on budget, desired functionality, desired quality in a sustainable way. And I think we can agree, if we do this, we're doing pretty darn well right off the bat. But that's not exactly what I mean by 10x. I think this is good. I think this is great. I think this might be 4, 5, 7x, but it's not 10x. And so what do we sort of mean by 10x? Well, sort of what we mean by 10x a little bit is this idea that we've seen through lots of different studies, and here at Construx, working for Steve McConnell, I get to talk to thought leaders all over the world, and I have visited companies on almost every continent. Well, yeah, every continent. I've visited companies just practically on every continent. Well, Antarctica, no. So what we've seen here is that there is totally demonstrable evidence that there is at least a 10x productivity difference between different kinds of things. And I list three of them up here between developers working on similar systems, different kind of design approaches, and just different organizations working on similar kinds of problems. And it's not just 10x. We've seen 15x, 20x, 30x, and we've just seen practices that have driven productivity a huge amount. So what is it that makes 10x different from all these other people? Well, I think the 10x development difference is really this, that to be 10x, that you have to do those 5 success factors, that being on time, on budget, desired functionality, desired quality level, sustainable, at a fraction of the cost of other companies. I think that's what 10x really means here. It's not that we're being productive. It's not just that we're shipping software, but we're doing it at a cost and a speed that just dazzles everyone else. And to me, this little quote attributed to Henry Ford, the guy that started the entire industrial revolution with his mass production of cars, in a sense, said, an engineer. And I like to think software in a sense is an engineering activities to a certain degree, because it's like saying, how do I take these elements and combine them into something more interesting? And an engineer does for a nickel what any damn fool can do for $1. I think that's a great quote, and it's something that I want to keep in mind as we look at the principles that we're going to be displaying up here, that we want to say, how do we apply those principles so we can do for nickel what any other fool can do for $1? And so what we're going to look at here is these 10x development principles. Now, each of these principles, there's going to be 8 of them in total here. And for each of these 8 principles, I'm going to start to look at a few tactics, or just sort of highlight some tactics, because this is obviously a short webinar. We don't have a lot of time to go into a lot of detail on all these things, but I at least name these principles for you, give you an understanding of how those tactics works, so you can start seeing how you can use those tactics in your world to start trying to drive up your 10x development practices. And where we got these principles from is from our years of consulting here. We've been in business since '96, and we've visited companies, again, all over the planet, and we've seen what really drives this kind of work forward. And so we named these principles. Now, somebody else could take a look at these same kind of things and maybe come up with 7 principles or 9 principles and give them probably different names. And that could be. But it certainly is a way to start here. We're going to start with R8, look at those tactics, and then you can decide whether that starts to make sense for your organization and how you can apply it going forward. So we'll name the principle, look at some tactics, and we'll briefly go through those, and I'll leave plenty of time at the end for some Q&A. So my first principle, number 1 of 8 here. So we got those 8 principles. My first principle is called avoid -X development. Now this one is I think hilarious. This is the kind of things, you see my image here of the person about to step on the old banana peel, if you will. This is where we shoot ourselves in the foot. We know we shouldn't be doing these things, but we do them anyhow. We set a date without any rationalization besides we want to have that date. That's minus X development. Sure, you can set a date, but you have to understand if it's the right package of work to be able to hit that date. It takes a little bit of analysis, a little good estimation practices, and it's not just making stuff up. So minus X development. In fact, let me give you a sense of how that actually may look on a real project. So a typical minus X project might look like this, is that the business identifies a feature set and selects a delivery target. They name when that needs to be done. The development team looks at this and says, ooh, I'm not so sure about that. I think that delivery date's a little aggressive given all the things you've asked for. And the business listens carefully and says, yes, I understand these features are pretty aggressive, but we got to have it by that date, lest the company totally implode. So what we do is the leadership, the technical leadership, divides the work and decides in sprint, we'll get this much work done in sprint 1, this much work done in sprint 2, this much work done in sprint 3. Looks like we're going to have 10 sprints overall, whatever, we're good to go. And do we have time to start refining the backlog and getting them into a really ready state before we even start the first sprint? Nope, there isn't time. We've already got work assigned. We've got to get cracking on cranking things out because we've already got goals in that first sprint we got to meet. And so what do? We just assign stories to each developer and get coding. And this is a very common practice in my minus X projects. We just take the story, say, you go write this story, and off you go. And as the team starts working their individual stories, the individual team members start working stories, they start finding details missing that we never found because we didn't do that refinement in the first place. And then we have to go back and resize it and rethink it and redesign it. And of course, this starts to slow our throughput down. Our velocity is our throughput, and that starts to slow down. And then the team gets stuck on some poorly emerged design choices. That because we're all working individually, we're not doing collaborative work. Everyone's sort of designing their own part, and they're not integrating as well as we thought. And so what happens again? The velocity slows further. And then, of course, because we're trying to meet those sprint deadlines, we're cranking things out, but we're not really fixing the bugs as they come up from earlier sprints. So now all of a sudden we have this huge amount of technical debt in terms of bugs that we have to fix, and we have to start shoving those in, which slows our velocity even further. And then what's really scary is then, and this is sort of the epitome here, the team starts cutting epics or work we've already done a lot of work on because we had such a high amount of WIP, we had all these bugs, and then we had to start cutting them because we didn't have time left. The date was fixed. And so we start cutting out this work. All that work is waste. So we're not going to be on time or on budget or on the functionality desired. Obviously, we're cutting here. And the team is going to be burned out, hating this, and the quality is already suffering. So that's your typical minus X project. And so what happened to drive all those minus X projects? Well, we tended to create what we call classic mistakes. And you can find an updated list of our classic mistakes on our website at construx.com. But I just want to highlight a few of these the 4 areas we kind of categorize these classic mistakes that we see over and over again that drive the minus X. There's a whole bunch of people-related mistakes. When I talk about people-related mistakes, the most common one here is wishful thinking. Wishful thinking says, gosh, maybe we'll get lucky this time. Maybe those things that have happened in the last 6 projects won't happen on this one. Maybe no one will get pulled off in an emergency situation, right? So those are one of the most common ones I see there. Addition to the unrealistic expectations. This team of 2 people can do all this work in 3 days. Or if we just throw bodies on it, somehow it magically gets easier to work on. So people-related mistakes. The second main category is product-related mistakes. Product-related mistakes are all about how do we define the product and understand the product. And the 2 things here are really interesting that stand out to me. One is gold plating, because I see gold plating in 2 different ways. I see gold plating in terms of the stakeholders asking for more things than what they really need. Their minimum marketable feature set is loaded with things they really don't need to be minimal to get feedback. And there's also gold plating from the developer saying, I have to build all this infrastructure before I can release one useful thing to the customer. Otherwise, I can't do anything. And that's just not true either way. So we see gold plating on both sides. Ignoring the done definition is one that showed up on the list recently. Ignoring the done definition says we've got this list of things to maintain quality in our software, but we don't have time, so we're going to move it. So that's the second category. The third grade are process-related mistakes. Very common ones here. Risk management's been on this list forever. wasted time during the fuzzy front end. This is what I still see even on my Agile projects, because what there's happening here is that someone has come up with a date, but for the first few months, because that date's maybe a year out, we don't do anything. We're not refining the backlog. We're not trying to understand the customer better. We're just sort of doing other work, and all of a sudden that deadline keeps showing up and showing up and showing up, and all of a sudden we don't have time to do it all. So we wasted a lot of time in the front end. Planning to catch up later is another interesting process mistake. I see this still on my Agile. They have this long backlog, the deadline's set, but the deadline is set because Agile lets us do that. But we keep thinking we get all this backlog, and it's like, oh, we'll catch up later. No, catching up later doesn't happen. And finally, the fourth category is technology-related mistakes. And the big gorilla here is the silver bullet syndrome. We, as an industry, as software developers, love our silver bullets. We love being able to say, this next methodology, this next practice. If I just adopt the Google approach, I remember it was the Microsoft development approach, and now we have the tribes and all these things, and then Leave and DevOps, or even a seminar from Construx or a webinar is going to solve all our problems. We're always looking for the next silver bullet. And Fred Brooks famously said, in the 70s, there are no silver bullets. And then a guy named Barry Bain came along and said, and very few copper ones either, right? There's very few things that are going to make us better. How do we actually get better? How do we start to avoid -X development? Well, I think one of my main tools is the old plan, do, check, act. Or, as we like to say in Agile, inspect and adapt. These are the tools to help us avoid -X. We analyze or we inspect what's going on right now. What is actually happening? And then we try something to improve it. We say, we're not going to do that anymore. We're not going to accept that status quo anymore. We're going to say, we're not going to accept wishful thinking. We're going to try to learn how to estimate better. Or we're not going to accept the fuzzy front end. We're going to try doing some initial planning up front or some initial refinement up front. We're going to create an experiment, and then we're going to watch what really happens based upon that experiment. And sometimes it takes 3, maybe 4 cycles, maybe up to 5 cycles to actually observe that well. Did it really work? And then we decide and refine whether I accept that as is and then go find the next problem to work on, or try modifying or a different experiment altogether. I like to call it AXOR because it sounds way cooler than plan, do, check, act to me. So I call it AXOR, analyze, experiment, observe, and refine. Actually, honestly, I originally called it AOR, A-E-O-R, but someone said that sounded like a donkey from Winnie the Pooh. So they said, how about AXOR? And I said, well, that sounds manly. I like AXOR. So AXOR it is. But you can use plan, do, check, that. You can do inspect and adapt. But there's this little cycle, right, that is saying, let's see what's going on. Let's try an experiment. Let's see what that experiment output is, and then decide what to do about that. So that is our first principle. Avoid -X development. Get yourself out of it to a tactic like plan, do, check, act, or expect and adapt. The second principle is seek ground truth. This is maybe not such an intuitive model, but the idea here is, this principle is that we do not make decisions based upon reality itself. We never do. We always abstract it to some level. We create some sort of model. And that's why I have a picture of various kinds of UML models and such up here, is that we create models of the world and we make decisions off the models, right? The models could be an estimate, a project plan, a UML diagram, a backlog. A backlog's a model of what people really want. It's not the thing itself. It's a model of it. And ground truth says, does our model represent the reality well enough to make good decisions? Because it comes from the old saying that when a map and the terrain disagree, believe the terrain, right? This is, I've heard it attributed to everybody's different army, right? But the thing is, the terrain has ground truth. That's the idea of ground truth. It's real. The map itself is an abstraction trying to help you, but you're making decisions off the map. And so how do we make sure we have good ground truth? How do we make sure that our models, our plans, stuff like that have good ground truth? Well, the tactic here, it's still a tactic, let's call it. But the truth here is that past performance on almost all our software projects is a relatively good indicator. It's probably the best indicator for future performance. I was just with a team 2 weeks ago, and they were working on issues, and they said, well, every project is unique. I said, well, then you have a good history of working on unique projects. And the way you work on the next unique project is going to be always similar to how you worked on the previous unique project. projects tend to be, that's the way you work. So your past performance on unique projects is going to be a really good indicator on the next unique project. So we have to collect that information. We have to create some sort of collection to say, how do I understand that past performance to help me understand the future performance? And that's the way to sort of connect up and have that ground truth. Because what we're really trying to do here is to create these cycles of evaluation and prediction. That is, here's where we think we are, here's where I think I'm going to end up. Now, how did that turn out? Evaluate it again, then make a new prediction, evaluate it again. And what drives this, and this is where I think I like to claim Agile is really an enhancement to our software development practices because it allows us to have smaller batch sizes. And there's a lot of power that breaks through with a smaller batch size because you can create these cycles of evaluation and prediction faster, faster, and faster. And that's really one of the keys to getting ground truth is how fast you can keep these cycles going and with the minimum amount of overhead. So what do we need to do? Well, we need to look at ground truth in those 4 areas that we really care about. In fact, we should probably add a 5th one on here. We got schedule, cost, quality, functionality, and probably want to add team happiness here as well. How happy is actually the team? Keeping an eye on that. And that's where we can use our retrospectives if you're running Scrum or some other form of Agile that uses them, because that's where we can start doing this on a really rapid basis. So the second principle here is seeking ground truth, and the way you get that is through evaluation prediction cycles, and that's enabled by small batch sizes. The third principle here is base decisions on data. I actually like to sort of break this into two. First of all, make decisions, darn it. A lot of our teams are paralyzed by this ongoing lack of making any kind of decision whatsoever. And we really need to make some decisions and move forward and learn and adapt. That's the Axor cycle again. Let's do an experiment. Let's just try something. But if we're going to do it, let's try to do it based upon data. Now, I think when people think of data, they think of metrics. And I just threw, we have in beta, just coming out of beta pretty soon, my Agile Team Metrics course in our on-demand at Construx.com. But here I want to think about data a little different. I want to think about evidence, things that I can point to say, is this true? And so the tactic, or one of the things you might think about as you're trying to make decisions on data, is really, where am I getting my evidence? Because I think there's 4 main areas that we need to understand and get evidence from. And if you don't have good evidence that this is a good decision from all 4 of these areas and has reasonable support from all 4 of these areas, your decision is going to fail. That is, it's going to be ignored, and it's just not going to turn out wrong. It's just never going to be implemented. And those 4 areas are organizational, best practices, ground truth, and human. Let me just explain them briefly. Organizational is, do we have the will and the means as an organization to make this happen? For example, let's say that you're a brand new group just deciding to go Agile for the first time. You decided that, hey, it's been 20 years, let's try it. Well, is the whole organization behind it? Are they willing to support it? Are they able to drive it forward? Are they interested in making this happen? Are they sticking with it? Are they providing budget? Those are the kind of evidence you'd be looking for to say the organization supports this. How about best practices? That's the second area. Best practices, what evidence do we look for there? Do we have the tools and training to make this happen? Right? It's one thing to say go Agile or attack that technical debt or implement DevOps, but not if you're not giving us the tools and the training to make it happen. We're going to feel frustrated. We're going to feel out of our league. Reading a book, having a brief seminar is probably not enough. The third area is ground truth. What's the evidence here? The ground truth evidence we're looking for is, what's the situation on the ground? Is this the right time and place to take it? I might be doing it with the wrong team. I might be doing it the wrong time. We're just on the edge of a major release. This is not a time to change the entire development process, right? So what's the ground truth say about what's going on? And finally, human. Human, the fourth area. How will human beings react when they do this? How will they start feeling when you do this? If they're not on board, if they're not supporting it, you're dead in the water. For years ago, I used to work for a government agency which had the leader rotate through every 3 years. It was a military, usually a colonel. And if we as a team liked what they were doing, we said, sure, we'll do it. But if we didn't like it, we would say, yeah, okay, we'll get to that. And then we just stall and stall because we knew they were going to rotate out in a few years and a new leader would come in with a whole new list of things to do. And we know our leaders tend to have short attention spans like that. And so if the humans on the ground are not accepting it, you're not going to have a bad decision. So I think one of the things to think about here when you're trying to say, hey, let's make decisions on data, based on data. First of all, do I have evidence from at least these 4 areas, and you can add your own if you wish, but I have evidence from at least these 4 areas that says, yes, this decision is going to stick. The other tactic that's really kind of cool here for make decision day is have a clear decision rule. That is, how are we going to go about making that decision? And so I put up a little chart I put together between how many people participate in the decision, from full to very little participation, to how long it tends to make the decision. And I put in blue, light blue here, those I think that make sticky decisions, that decisions that tend to stick, right? The lighter ones, I don't think to stick too well. Delegation puts it down to who's really going to be impacted by it. Those decisions tend to stick because they're the one living it out, they're doing it, those tend to stick. Consensus decisions, different than unanimous agreement. Notice I didn't put unanimous agreement with the blue box there because I think unanimous agreement is actually very hard to get. What I really want is that everyone support it, not necessarily agree with it. And everyone supporting it, even though they might disagree, but they'll get on board, that's consensus. So consensus says, I may not like it, but I will support you and the team. Decides after discussion is kind of in the middle there. It takes a little bit longer than sometimes, but it involves more people than delegation does. What decides after discussion says, I'm going to appoint a decider, usually just one individual, and that decider is going to say, let me listen to all the sides here. Let me hear what you think. And once I hear what you think, I'm going to then make a decision. But I'm going to have to hear everyone. Because it turns out most people don't need to have their way, they just need to be heard. So those are 2 tactics you can look at to help you make decisions based upon data, our 3rd principle. Our 4th principle is minimize unintentional rework. And I love the title of this one the most because it has 2 kind of interesting points. One is the term minimize, right? It says there's going to be rework that we cannot possibly get rid of, especially even on unintentional rework, things we didn't plan, things we didn't expect to do. The second one is unintentional, which sort of suggests there's intentionally work. And I think there is intentionally work. But the idea here is let's keep the ones that we didn't plan, the ones we weren't expecting, as small as possible. Because what drives this thing? What really is behind this? Well, there's a couple things here. One is our friend, the defect cost increase curve. What this is saying is that when we discover a defect, is different than when we introduce it. So over here you see it's introduced. Down here you can see where it's detected, right? And it says if we're right here and I introduce a defect during discovery, that is we're in backlog refinement. And in the refinement meeting we say, hey, this isn't making sense. And we send the product owner back off on a mission to find out what's going on. That product owner may spend 10, 15 minutes getting clarification because it's fresh. It's something they're working on right now. So maybe we were doing 15 minutes here, right? But let's say it doesn't happen there. We don't see it during backlog refinement. We pull it into sprint planning. We're in sprint planning and we discover the same defect there. Well, it's not quite as fresh to the product owner, and we're in the middle of sprint planning. We may have to put it back. It may be an emergency phone call. So instead of spending 15 minutes, maybe we're spending 40 minutes of actual overall effort. We've really increased the amount of effort, but not a huge amount, but we've increased the effort somewhat. Fair enough. But what happens if we don't catch it there? What happens we're in the middle of the sprint and we find the defect? Oh, now we got some trouble, right? Because it can change our entire design, our entire plan. We might have to scrap some work. We'll have to redo some work. So spending 40 minutes, now we're spending like 200 minutes of time fixing the exact same thing, a huge increase in cost, and it keeps on going this way, right? The defect cost increase is a truth about development, regardless of whether you're agile or sequential or spiral or whatever you are. This is just a fact of life. How big it can get might vary a little bit depending on how much we have to look through, but even our agile teams, it's going to grow substantially. And what does that turn out to mean in practice on our projects? Well, it means something like this. We have planned out to do some work, and anyone who's tried to fill up your Scrum sprint to the book, you've realized this is based. You've got some planned work. You think you've got it nailed down. You're ready to execute. And what happens in real life is that you get tons of unplanned variable rework. And on a poorly planned project or normally planned project almost to a certain degree, this work can exceed the planned work. That is, we spend more time in unplanned work than we do in planned work. So what does a good team do? What does a 10x team do that try to minimize unintentional rework? What they're going to do is they're going to have that same planned work because that's what you need to do to get the job done. But they're going to add a little bit of planned overhead. They're going to add some more work that's not necessarily doing the right thing. I think the Scaled Agile framework calls these enabling requirements or something. They're things we're going to do just to sort of say, hey, we got to take some steps to try to drive down that variable unplanned rework. And that's not, and this ratio is probably just about right, because a little bit of overhead can buy down often unplanned rework by a factor of 5. And what is this planned overhead? What does this work really look like? Well, I put a list in here of some examples you might be thinking of. Spikes can be an example, right? So the spikes from the architecture and design, some user interface prototyping, more formal look at requirements or stories other than just sort of taking them in, really thinking of stories as the whole conversation, not just the written stuff that we stuck in Jira, right? Collaborative coding, this is where we do pair programming. This can actually drive down rework as well, especially if you're trying to understand complex things. So there's lots of activities we can do to sort of drive that down. And so we can start really minimizing unintentional rework, our 4th one. Our 5 of 8, tailor solution to problem. This is a situation I see over and over again, and it still sort of bugs me when an organization says, we're going to adopt one methodology and everyone has to follow the same methodology, rather than realizing that every problem is somewhat unique and you need a somewhat unique solution. They're trying to say every solution gets the exact same problem, every problem gets the exact same solution, is kind of crazy. And think about it. I mean, just look at the products that we're working on, right? My card game over here, does it need the same kind of thing as my 737 MAX flight control software? Well, obviously the answer is no. My development methodology and my development rigor for the card game can be far less than for the flight control software. So all these different kinds of problems have different kinds of needs. I would not want to take the rigor I want to put over here and then shove it on over here. That would just be a total waste, right? I would be just screaming my head off. And so we've got to find the right kind of solution. And that's the same time with processes. Maybe I want a process that has a lot of flexibility. Maybe I have truly not a good understanding of my requirements. Truly, I don't have a good understanding of my design, so I want lots of flexibility. Well, you can see here that says predictability is going to take a hit, that I can't in any good amount of time predict how long something can take because I'm being totally flexible, right? It's like saying, what are you going to eat? Ooh, I don't know, but I'll tell you when I'm full. That's about it. That's all I can say. I can't tell you when, how long, how much, what I'm actually going to eat because I'm totally flexible. And so one process doesn't really fit all. But there is one thing that we can take when we try to tailor our solution to problem. We can look at the intellectual phases. The intellectual phases are ways of organizing, intellectual phases are what we have to go through to do any kind of creative work. The example I like to use is cooking. When we go into a kitchen, our hands just don't start preparing food for no apparent reason. We've gone in there already understanding the problem. We've already discovered the problem. For me, it's often I need to make breakfast for my wife and 2 daughters on Saturday morning. That's the problem I often get with cooking. Right? That's my job. And so I'm going to have to do that. I've discovered that problem. And then I come up with an invention to solve it. I'm going to make waffles and I'm going to get myself a waffle recipe, right? That's the invention. Start saying, what's my ingredients, what I have available to me. I'm going to come up with a solution. I'm going to choose waffles. So first I have to go discovery, what's the problem? Then I have to think of a solution to that particular problem. And then I have to implement that problem. I have implementation. I have to have the detailed timing, organizational skills, technical skills to actually pull it off. But there's also detailed design that's like, well, how long do I want to beat this egg, for example? Any creative work has to go through these 3 intellectual phases. And so we start to tailor the solution to the problem. We're going to say, what is the problem on this one? Does it have more discovery work? Do I need to up this game and I can down this game because the major issue is overall discovery work? Or is it maybe implementation is the big deal and I can down the game here and down the game here, right? Or maybe you're saying, no, we know what we need, so we can down the game, but invention's hard, but implementation is going to be hard too. I need to adjust my practices given what the problem really is and try to minimize the amount of overlap between all these things. And this is where, again, Agile can be really helpful because we're going to come up with a plan every time. This is how do I want to adjust my plan to deal with the intellectual phases I need to execute. And so I put in here something from my larger 10X classes here and saying that we really should have a toolbox approach. There are times when code and fix actually may make some sense. If I'm doing a rapid prototype, Code and fix might be the right things. I don't need to worry about these other things. How uncertain are my requirements in my design? How reliable a product do I really need to make? How enhanceable is this product going to be in the future? How do I deal with project risk? How do I deal with the idea that people want to change directions? How visible is my work product? How am I able to constrain to a schedule? And how smart, how sophisticated do I need to be to run it? With code and fix, I don't have to be very sophisticated at all. I can just do it. In fact, I think this is the default methodology. But if I really want to learn something like Scrum or evolution delivery, I got to really up the game quite a bit. I got to be really kind of smart to run this well. It's simple to understand, but it's hard to run it well. So I've got to come up with a toolbox approach and say, given my problem, what is the best solution? And that's what my 10X teams are doing. They're not trying to make sure everything fits the same pattern. They're trying to be just similar enough that when people jump from one ship to the other, they understand that we're going to come up with a new solution to this particular problem. 6 of 8 is attack uncertainty. This is a big problem on projects because it turns out human beings do not like uncertainty. They would rather have tons of risk than say, we're not sure about something. We're uncertain. But there's tons of things that we don't know about. And this is like to have my Donald Rumsfeld moment, right? For those who have, again, the gray all over, we might remember Donald Rumsfeld is a former Secretary of Defense, and this is one of the things he got chided for with his little speech here that I'm quoting. As we know, there are no knowns. There are things we know, but we also know there are known unknowns. That is to say, we know there are some things we do not know. And that's just it. We know there are things we do not know. Now, this third category down here, there are also unknown unknowns. There's not much we can do about that, right? We can leave some buffer, but even then, it's just total guesswork. But there are some things we can do about this one. This is the one that we really should be doing more about. And when we say attack uncertainty, we're talking about that middle bit there. How do we deal with the known unknowns? And there's two flavors of the known unknowns. One is the flavor of inherent uncertainty. Inherent uncertainty is the natural variation we get on any existing process. This is what Steve McConnell named the count of uncertainty. It's his variation from Barry Bame's work, where he talks about product effort size and features. And I want you to we can ignore this side of here because that stuff is Steve made up. This is the real data is on this side. The real data is on this side, so don't worry about the project schedule side too much. There is some rationale for that, and if we want to get into that in the Q&A, I can explain it. But the idea is that professional estimators, when they were thinking this is going to be a 12-month project, 12 months of effort, could be off by a factor of 4, easily. And it wasn't because they were stupid or they're bad, but the inherent uncertainty. The example I use to a lot of my classes is driving to work. You know your work commute. You've driven it many times. But I've asked you to bet on the next day exactly how long it's going to take you to drive to work to the minute. How much time will it be elapsed from the time you leave your house till you get there? Most people aren't willing to take that bet if it's any kind of significant money because there's stoplights that may or may not happen. There's other cars that may or may not happen. There might be a railroad track they have to cross. All of these things lead to this inherent certainty. But for software projects, that inherent certainty is baked in the front end. And we've run this well. We start working it, we start working the project, we will naturally drive down if we do a decent job. If we don't do a decent job, we can easily stay in a cloud of uncertainty, right? Because we have to actually work it down. We have to do things like decide what the problem really is, right? We have to do discovery. We have to do invention, right? We have to do the intellectual profile work. If we don't do that work, we live in a cloud of uncertainty. And this happens at the big project level. And for our Agile folks in the audience, it happens at the story level. Every story goes to its own little cone like this. It's not months long. It may be days long or even a week or two long, but it's still the same thing. And you have to go through discovery, invention, implementation. You have to do that work to make it happen. And pretending like this doesn't exist at the beginning is just not attacking uncertainty. It's going to make us do all kinds of crazy things. The other kind of uncertainty is known as special cause variation. Special cause variation says these are things that usually don't happen but could happen. What's interesting is about the inherent uncertainty is that you cannot plan this away. Thinking about it does not make it go away. But for special cause variation, we can do risk management. Risk management says we're going to identify the things that normally don't happen but could happen, and then do something to mitigate it. Something in our risk control section over here, something to make it either less painful if it did happen or make it less likely to happen. And so a good risk management program is a tactic we've been using for years to try to deal with this. Now, it's really cool on our Agile project on the Scrum team. For a given sprint, usually we can bake that in because risk is not a big deal sometimes on that little bit, but there's still big risk on the big picture that we still need to address and take care of. So our 10X teams, even in our Agile environment, are still doing a good level of project risk management. Number 7 of 8, set direction. Set direction says, the idea behind this principle is that if I know where you're going, if I know where you want to go, I can help you get there. If I'm not clear to where I think you're going, I'm going to take whatever route I think is best. Now it's up to me. So set direction says we need to be able to set clear direction so people can fill in the blanks so they can know where we're going. Because when we have lack of direction, that's where we see a lot of problem. And we seem to be getting lots of lack of direction from the top right now, right? That the whole how do we feed a good Agile team or a good project team is really it's always been an issue, because when people do not understand what they're really trying to achieve, and by the way, make everybody happy, do everything is not direction, right? It's just total abdication. Because direction means you have to make a choice. You have to make a commitment to something that's achievable and doable. Making a commitment to something that's not achievable and doable is nothing more than wishful thinking, one of the minus X things. So when we have lack of direction, what's going to happen is everybody's going to decide their own direction. Because they have to. They have to get work done. So they're going to decide their own direction. And when they decide their own direction, the probability of them all deciding to go to the same place, pretty much nil. So we've got to set direction. And I think there's 2 kinds of levels of setting direction here. One setting direction is from the leadership position. And I think they do it in 3 levels, large, medium, and small, at the leadership level. The largest one is the product vision. The product vision is a statement of exactly who this product is for and what main things it's supposed to do and how well it's supposed to do it. So 3 things in a good product vision. Who is it for? What is it going to do for them? And how well does it need to do it? So for example, and I like to use in the class, if I'm a toaster, who am I a toaster for? Am I a toaster for a single person living alone, has lots of time? Or am I a toaster for a large family that's always in a rush but has very little counter space? I'm going to make a entirely different product for the one versus the other, right? But I have to understand who's it for. If I try to make them both happy, I'll probably end up with mush that neither of them wants to buy. So product vision has to make those large choices. Now, product vision stands over multiple releases of a product. So we often have a product roadmap. And we might say, here's the features we want to get to first. Here's how well it needs to work in the first quarter, how well it has to work in the second quarter, and so on. And so what we start seeing here in the product vision is a roadmap of how we're going to improve that product, doing that same thing, but how well it's getting, how it's getting better, and maybe the features we're going to introduce to derive how well it's going to do better. And then from the leadership thing, what are the small releases and implementations we're going to do to implement the roadmap that's going to overall solve the product vision? So that's the leadership we do at the leadership level. I also think we have it at the team level. The team level says, in the large, what's our overall product backlog? So what's the look like here? And that's going to overlap a lot with the product roadmap and the release roadmap. At least its sorting should, right? And then in the medium, we got the sprint backlog, that's 2 weeks. And then the small is very small at all, the daily scrum. The daily scrum is not a status meeting for our 10X teams. For our 10X team, the daily scrum is a direction setting. What are we going to do as a team to help drive this product to completion? Right? It's not what you're working on and go off and have a good time, but how are we going to work together as a team so our direction is clear so we can then work individually to move the team forward together. So daily scrum, again, is not a status meeting for our 10X teams, but it's a direction setting meeting for the whole team. And finally, number 8 out of 8, grow capability. Growing capability is saying, how do we constantly get better so we even get more productivity as a team? And I think the big trick to growing productivity is just understanding professionalism. You know, one of the things I get tired of hearing a little bit is that individuals saying, oh, I'm not paid to do that, or it's not my job, or I only do this. And it's like, wait a minute. You're typically, if you're in the software world, a relatively highly compensated individual overall. You are a professional. You're receiving good money to do a job for the business. And to be a professional, because you've got to have pretty good and intertwined understanding of the technical fundamentals, the management fundamentals, and the quality assurance fundamentals, which maybe you can swing under the technical fundamentals, but there's enough body of knowledge underneath that typically to sort of squeeze it out by itself, right? Similar with the management fundamentals. And I've put up example books here, the SWE-box, Software Engineering Body of Knowledge, the PM-box, Product Management Body of Knowledge, and Jerry Weinberg's Quality Software Management, especially Volume 1, I think is excellent. But the pair that with the testing techniques by Boris Beiser, I think is a really good combination there as well. But saying, do we have a fundamental understanding of these kinds of things? And then we can sort of drive that capability growth into three main areas. We can build it in terms of enhancing individuals. And here we think about senior staff. And when I say senior staff, I mean people have three real capabilities. One, they understand the technology, i.e. they have all the, being professionals here, right? They understand the technology, but also they understand the business domain. Because if I understand the technology, but I understand what business you're in, I'm going to build cool things that no one can actually use. And the third thing, they have to get along with other human beings. That is, they can't be a pariah that everyone hates. They have to interact well. 2 out of the 3 usually gets me in trouble. I need to have all 3. And the hardest one to hire off the street, well, human interaction is pretty hard to hire. Technical one's not too hard to hire, but business domain's almost impossible to get. So that means I'd have to have some kind of professional development, some way to grow this stuff. So I need to enhance individuals. I also want to enhance teams. I want to make sure I have the right size teams. Throwing bodies on things, we have lots of studies that says that just doesn't work. My 10X teams, what they're doing here is that they're sizing them correctly, using that 7-ish number as a good rule of thumb. 7 seems to be roughly around 7 seems to be a magic number, but then using it in a collaborative way rather than a series of parallel individuals, taking the power of the team to really solve problems, because we can do things much more effectively often as a team than we can as a series of parallel individuals. And finally, building capability in my environment. How do I do my thinking? Yes, I have collaborative thinking time, so I need some collaborative space, but I also have individual thinking time where I need to think by myself. I need to have my head in gear. And how do I make sure that happens and that I have information sharing between those two? How do I force the collaboration when necessary and yet capture knowledge when not? And how do I make the people feel in the environment that they have the tools and techniques and authority necessary to actually do the right kind of thinking in the right kind of space? I need to build that capability as well. So those are some tactics to help build capability. And one of the ways you might do that is to build yourself a capability map. And it might look something like this. You start off by saying, what is that people need to know? What is the areas I need them to have capability in? And these are some categories that we used from the Software Engineering Body of Knowledge, slightly modified. And said, here's some things that people need to know. And you can start thinking about their capability. How good are they on those areas? Introductory, I can do this, but I need someone else to check my work. Competence, I'm good at this. I'm your day in and day out professional. This is a very happy place for me to be. Leadership, not only am I competent, but I help mentor the introductory people. I am the go-to person in my organization for this area. And once you've got that, you can build a grid. And in this grid, for every cell, you can say, what is the knowledge I need to have to say, yes, I'm introductory in this case, construction, but also what experience do I need to have? How have I demonstrated that in real life at my company or previous companies that you have confidence in that say, yes, I've actually shown that I've understood this and I've applied it appropriately in the right environment. And this is where a great internal mentor program can actually help you build that capability as well. A lot of my 10X companies are doing that kind of thing, right? So that's number 8, build capability. So my summary here, my 10X sort of zoom in here, what it really looks like to be a 10X software development, these principles. These are teams that are using great teams and individuals to do these 8 principles. Avoid mindless engineering, saying we're not going to do something to shoot us in the foot. We're going to start doing a little fast evaluation cycles with AXOR, analyze, experiment, observe, and refine to actually avoid this. Then we're going to start using those same cycles to make sure that our models have ground truth. So we're making decisions off the right things. Our decisions are based upon data and evidence from all 4 areas. And then we're adding little bits of planned rework to avoid massive amounts of unintentional rework. And that allows us to tailor the solution to the problem each time. And we attack uncertainty by not just wallowing and doing that minus X of wasting the front end, but actually starting the project, working it, and doing some risk management, all while setting very clear direction to the organization and helping people grow their skill sets. So that's the 8 principles. I'll put those back up here for a moment, but that's the end of my presentation here. Both my contact is both on the front and the back. In the files section, I put if you wanted a copy of these slides, I put them in the files section of the Webinar Jam environment. And I'm now ready for any questions that you have. If you want to just type them in the chat over on the sidebar, if you didn't see those little red dots, there's a thing that comes out. The second one down is the chat, right? And so go ahead and ask the questions. All right, we do have one question coming in already. Question number 1. The 10X principles seem to apply at the team or organizational level. Do they apply at the individual level? Yeah, that's a pretty good question. I actually have been going through and creating a seminar here at Construx for 10X principles for individuals. And some of these are kind of a stretch. I wanted to use the same name so I could have coherency between the two. And I think, yes, they are pretty much, I can apply them. But what the trick here is the tactics are very different. Because when you start talking about personal level, we're talking about trying to grow your own personal skills. Obviously, the grow capability one's pretty good. The set direction one I can do pretty well. But things like the unintentional rework and the ground truth one, that's the one I really, and the minus X, what's minus X in the individual? And it's often assuming people think like you do. People think like I think. And so minus X for like this one, on the individual level, it's all about how do I understand other people? How do I get into their head? How do I have empathy for them? How do I bring them in? And so, yes, I think these principles do apply, but the tactics are often a little bit different than what I described here. So, good question. And if you're interested in that, you can send me an email, and I'm happy to send you my deck as it stands right now so you can get some sense about that and give me some feedback and maybe up the game a little bit. Okay, another question coming in. Oh, here's another question. Which of the 10X principles is hardest to get right? Ooh, yeah, which of these are hardest to get right? I mean, I've seen a lot of failure on a lot of these things from a lot of them, but which one's the hardest to get right? Looking at them right now, tailor a solution to the problem. Yeah, I think a lot of teams do that okay. Attack uncertainty, sometimes, while I think they all have their challenges, attack uncertainty sometimes seems the hardest to me because, again, the human nature does not want to have uncertainty. They want to have risk instead. They're willing to accept tons of risk, which they do nothing to mitigate, by the way. They just say, yeah, we're going to accept that risk as a risk. Oh, well, if it happens. And they're just shooting themselves in the foot. It sort of slams back into a minus X engineering habit. They don't attack it. They just want to pretend like it doesn't exist. So perhaps that's sometimes the hardest one. I usually get people to set direction if I talk to them enough. Base decisions on data, look at the evidence source. I think they're usually on board that one pretty quickly. But the attack uncertainty seems to be pretty tough. So I'm going to pick number 6 this time. You asked me that question. The next time I do this, I might turn it to something else. Okay, another question coming in. Oh, question. How important is mentoring into growing capability? So yeah, that's a great question. And I don't think mentoring is critical. I think it's helpful. Mentoring, I think, has two things. One, if you've done this ladder kind of program, growing capability, if you've got a good ladder and know where to go, most individuals can go there themselves. We used to have here one at Construx, and it was just plainly clear what you needed to do to improve. And so most people were pretty much on their own. And the mentors there were there to help answer questions and also act as a resource to the manager because the mentor had been on that path before, and then they know if they actually read the books or attend the training because they could ask and talk about it, and they could say, oh, you never went there. So it was an aid to the manager often more than an aid to the person, but also to have someone knowing that they've gone there before. But often, if you've got a smaller team, if you're doing that 7-ish thing to tailor solution to the problem and have the right sort of team size, then you're going to have someone on that team often that's been there before, and they're going to act as a mentor anyhow. So I don't think formal mentoring is critical. I think it's very helpful. But it's not a stopper helping to grow capability. So thanks for that question as well. Question number 4, is there an organization, you have seen this 10X. Oh yeah, I've gotten that question before. When I teach my 10X class, they say, name me 10X organizations. And total honestly here, the companies that call Construx are ones that want help. So they're usually not the 10X people that are just firing on all cylinders. So where do we learn about them? Well, I learned them, first of all, through my boss, Steve McConnell. Steve McConnell, with his prestige, gets invited to just be doing pep talks at 10X organizations. They're not there for help because they're so good. They actually try to just keep sharpening the saw, and they bring him for pep talks. He goes, investigates, and he comes back and tells us about them. So I've heard them secondhand, though I didn't get to visit them personally. And we have some case studies about organizations that are doing for nickel what any darn fool can do for $1. So we do have that as well. I've seen bits of 10X, though. I have seen maybe 7X, 8X, but honestly, I haven't been totally 10X. My boss gets to go to those. I get to go to the ones and try to get them on the road to 10X. And so I help them start solving those problems along the way. So that's a great question. Okay. So that's the question. Are there any more questions out there? Okay. Well, those are the main questions that were asked. I see something here popped up, said essential roles for a structure for a team of 7. The team of 7 thing just comes out of a lot of different kinds of work. The teams of 7 is about how many brains can we align? Because when you're doing teamwork here, we're doing knowledge work. And the knowledge work basically says, I got to take a bunch of brains here. Right, here's my brains. I've got to connect all these brains to make sure they're all going the same direction. And after about 7, this thing really becomes difficult to do, this connecting of brains over here. And so we really start saying, you know what, let's not do that anymore. Let's do something different. That's where it comes from. It's like, how do we keep the brain through all the knowledge work? So, okay. So I saw that as well. I just want to mention it because that's a really important concept. But my coworker is saying, I'm going to leave you time to get to your next meeting. So I'm going to wrap it up here today. My email address and all that, again, is on the contact page here, both on the front and the back. You can download that from the file section or send us an email here to me at earlbeede@construx.com or info.construx.com. And we'd be happy to send you out a copy of these things. I thank you for hanging out with me at Construx for 1 hour talking about 10X software development. And I hope we'll see you on our next webinar. Have a great day.